Well, this is continuing on with section 2.7. Sometimes the force is given to you already in Cartesian coordinates and Cartesian description, and maybe we want to find out what the magnitude and the unit vector is. So here we have a force that's described by this, and let's find the mag and the unit vector. All right, let's say that it goes negative 300. Here's our x, y, z axes. We'll just put those on there. So it goes negative 300 in the I direction, positive 400 in the j direction, and positive 200 in the k direction. Well, we can see where it enters or where it ends, and it's right there. So let's draw the force on here, and we'll call that force F. All right, so the magnitude then of the force is determined by the square root of the sum of the squares, 300, 400, 200. And again, that 300, we don't have to put the negative sign in there. We can just square it directly, and we'll get the magnitude, 538. Probably should have some units on here, so let's call this newtons, and I'll say that's newtons up there as well. Now, how do we? That's just the magnitude, but we do know that the force vector description of the force is equal to the magnitude times the unit vector. So let's go ahead and put the unit vector in, or the magnitude in there, and then the unit vector is the vector description, Cartesian description of the force divided by the magnitude. And you can put all those in there, multiply all that out, and now what we have here is the unit vector times the magnitude. So you can work backwards, and it works just fine. Well, the last thing we want to do in this section is try to find the resultants of two forces, and first we have to find the Cartesian description of each force and then add them together. All right, so here we have two forces coming from point A. Obviously this one's 840 newtons that way, 420 newtons in that direction. So let's find out what see if we can describe those two forces. So let's look at force B first. FB is 840 newtons. So in this case it goes from A. So in the x direction it is going to go 3 in the x direction, negative 2 in the I direction, and I guess we could start right there. You go negative 6 in the k direction. So let's go ahead and put all those in there. So I'm going to say that the unit vector of A to B is equal to 3i minus 2j minus 6k over the square root of the sum of the squares and we can get that, multiply all that out. That's equal to 3/7 I minus 2/7 j minus 6/7 k. Then again, FAB is equal to the magnitude, 840, times the unit vector. And here's where you have to make sure you put units or put vector descriptions on each one. So that's going to be FAB minus 2/7 j minus 6/7 k. Then go ahead and multiply all that out. 360i minus 240j minus 720. Okay, there we have the vector description, the Cartesian description of the first force. The second force is similar, so I'm just going ahead and complete that for you. First of all, we're going to go negative 6 in the k direction, positive 3 in the j direction, and positive 2 in the I direction. So this then is the calculation for the unit vector for AC. Calculating the unit vector then and multiplying it by the magnitude 420 will give this vector description of the force. So when you add them together, you just add the I components. 120 plus 360, you get 480. 180 minus 240 is negative 60J. Negative 720, negative 360, negative 1080K. Anyway, there's the resultant. Now, a common error for many students that many students make here is they forget to divide the vector force by the square root of the sum of the squares, and they'll leave out that 7 here, or the square root of the sum of the squares. For example, FA in this one, this is what the force should be, and that's repeated here. It should be this, where you got the description of AB divided by the square root of the sum of the squares. But again, quite often students will describe the force like this and forget that denominator, and if you do that, obviously you get the wrong answer. So that's incorrect. Alright, now I want you to pause the video while you work on this problem. This is a fundamental problem that you should be able to do now. Find out what the unit vectors are, what the vector descriptions of each of those forces are, and then add them together to get the resultant. So if you pause the video while you work on that, then I'll show you the solution in just a second. Well, here's the solution to this activity. So what we're doing is we're going from A to B on this force and A to C on this force. So let's track the path from A to B. So from this, I'm going to go that way in the I direction. So that's negative 2 in the I, negative 6 in the K, positive 4 in the J, and then back up, positive 2 in the K. So you add those together, we'll get negative 2I, positive 4J, and then negative 6 plus 2 be negative 4K. So there's our vector description of AB divided by the magnitude. There's the unit vector. Multiply it by the magnitude of the force. You get that as the total force. Similarly, from A to C, I'm going to draw that in a different color. So I'm going to go negative 2 in the I direction. Similar, back down 6 in the K direction. Here I have to go positive, or sorry, back negative again in the I direction, the X direction. Positive 3 in the J direction, and then back up again 4 in the K. So looking at the net, we got 6I, positive 3J, negative 2K. Doing similar process, you get the two forces. Those are the vector description of the two forces. Then you add them together, you get the resultant. In other words, you'll go 420, add to 200 would be negative 620, 210 and 400 would be positive 610, 400 and negative 140, negative 400, negative 40, and you get negative 540.